Finally, now we're going to move to our last speaker, Vinod, who's going to talk to us about some of the solutions he's put in place from a sort of the hardware and embedded software solution. Okay, so he's going to talk very much from the hardware and software solutions. Can you go full screen, please, Vinod? Okay, so on to our last speaker of today. It's Vinod Kumar Galla from Tesla Semiconductors, where he's a senior director. He has 25 plus years as an embedded software leader with hands-on experience realizing ideas to products in areas like automotive and SLT. He's based in Bangalore, and he's going to speak for the next 15 minutes on building the hardware and software for SLT Solutions. Over to you, Vinod.
Yeah, thank you, Mike. Are you able to see my screen?
Yeah, we can hear you and we can see your screen.
Yeah. Okay, I will take through the basics of SLT, what is SLT, why it is required, and also the importance of SLT. I mean, in the as I'll also touch up why it is important in automotive. Okay, if you see SLT, I mean, it's acronym system level test. Mainly, it enables the IC manufacturers to emulate the actual environment where it is going to be used. Okay, and then the main purpose of it is to test as a whole. See, in the 80 the previous development process, we test as a single model, but here we are testing the device as a complete system. I mean, all the peripherals working together. Individually, it is tested. Now we are testing all together, and then giving different types of clock, and then power, thermal, and all the software stacks working together. That is the environment it is used mainly to test the quality issues. Okay, if you see, I mean, the SLT right now there are three important markets which are being used. I mean, these are the major markets. One is the mobile phone, and the automotive, and then high performance computing. These are the three markets which are widely used. Okay, and I mean, even though it's an SLT, the requirements are different and they are unique. Okay, for mobile phones, we require I mean, the chip has to be tested the room temperature, and then that is the mandatory requirement. And coming to the automotive chips, we have a hard requirements that it has to be tested at -40 and plus 150 degrees centigrade. So all the features have to be validated, and also it is safety critical. Okay, coming to the high compute devices, mainly for large data analytics, and also in the automotive, it is used for autonomous car, where there is a huge data has to be collected and decision has to be taken over the data. Here, there's a chance of heating happen. So here, the main focus is to test it is not overheated. So we always keep at 125 degrees. And there are coolers installed inside the system so that it doesn't go beyond. So this is the main use case which is tested. Okay, let's move on. Okay, this is just a snapshot of how what is SLT and how it works. If you see here, we have a handler and we have a chip, and it is placed over here. And this is the actual environment where we place it and then we test it for the real scenario. Okay. Coming to actual embedded software development, what actually we test. Okay, here and also the test cases are automated. So what it is, let's see. If you see here, there is a, I mean, this is how we get the silicon devices thoroughly in all sense, mainly in the handler control and then thermal control, and the test cases are to be executed in sequence, and also the peripherals, I mean controller peripherals have to be tested, and also interaction between the peripherals have to be tested. These are the 4 main blocks have to be tested. Okay, what if, okay, normally all test cases pass and then it will go to the passed bin, okay, and then it is given to the, it goes for release. Okay, well, there are few chips which fail also. So those go to the fail bin, okay, and here in the fail bin, we also should identify why it has been failed. What is the real reason for failure? So this, there are logs which are captured for each and every test case, and also the sequence also captured, and then with this, I think it is easy to identify what the real is. Okay, coming to the software environment, normally this is one of the software environment which is which we are using for the SLT. So for GUI, we use C# as a development language, and for writing the test cases, we use Python. The test cases are written in Python, and it is executed in Python. And the source code, we use Git server, and then Visual Studio for compiling and triggering the code. This development, software development. Okay, let's see what is what is there in writing the test cases, and then the sequence of test cases, that also matters. Okay, here in the SLT automation application, what we do is we use YAML file format to write the test case. Okay, and then we first write the sequencer. See, we write the test cases for all the peripherals and all the boundary conditions, and then the negative test case, positive test case, all the test cases we write. And also they are written for module wise, and also we write a sequencer in which sequence the test case have to be executed. So that is what we call the sequencer. And then we also write a test code to execute it. So based on the sequence, it will trigger the it will execute the module test case one after that. Okay, and then the same as earlier I mentioned, the past test cases will have all the results, input and output, and if it is same, expected result is same, then it is passed, else it is failed. Okay, and then when it is failed, also it it also captures the detailed report for that defect. Okay, this is about software automation. And coming to the hardware, here I think we have to test for multiple chips, to complete the lot at a time. So here we have a handler, and then it can handle 4 chips at a time. So, and then we have 4 test pieces, and then all the tests are run parallelly, and the data is collected, and it's passed to the pass bin. Otherwise, it goes to, the chip itself will be pushed to the fail bin, and the handler here, it picks the chip and then places to the appropriate position for testing and trigger it. Okay, and here if you see, it also supports all the packages for testing QFP, TQFP, PGM, and so on. Okay, this is hardware environment, and then we also need to test for volume-based testing. Here, okay, there is a limitation that if you run a count as 1, okay, the test case might pass. Okay, in some cases, if you put the same procedure and test, if let's say 10, count as 10 or 100, it might fail. So we are also interested to catch such kind of errors. To improve quality of the silicon. Okay, and then we also have a few difficulties in creating the environment exact to the real environment. Maybe we have difficulties with the fragmentation of memory, and also some case maybe some tools combination the test case might pass, and then some other combination it might fail. So there is a challenge to find out what is the real reason. Yeah, that's it. Open to take it.
Okay, thanks, Vinod. Yeah, we have a few questions which you may be able to answer, or if not, maybe Stuart or Jürgen can answer. So the first question is, in terms of coverage metrics, do we have, are there any, can we quantify the coverage of SLT?
Okay, yeah, we have a metric that in case of automotive, we have something called ppm, parts per million. So, that's a metric, and we are achieving, normally it's 0 fails per million. So that's
I think it's more a metric, not on the DPM metric, but actually on the coverage that SLT you're able to get with SLT. So are you able to cover? Like in traditional tests, you can look at the fault coverage. Do you have a similar model for SLT? I don't know. Maybe Stuart can answer that as well. Or
yes.
But Stuart, you're on mute.
That's muted. Yeah. So the test coverage, it's really proprietary to the customer's application and what tools they put in place to monitor their coverage. Yeah, because these programs are tailored for the end application. So in terms of faults coverage, those trade-offs are being made by the customer in terms of the actual application that these parts are being put into, and often they'll be doing part harvesting based on the target application that these parts are going to be targeted for. So they have tools for monitor. So the customers have tools for monitoring based on their simulations and their test development and customer end application, and then there's system level monitoring tools that are available that they use as well. But most of that is proprietary and based on how they set up their test simulation with their end application users.
Okay, so
there is another point is also like Stuart mentioned, it's a left or right turn approach. There are possibilities to bring the structural test into the SLT, having SSN and other instrumental interface to get it done. So our traditional fault coverage, what we do in ATE, it's already happening. Some customers are already implemented to achieve an SLT. Apart from that, as Stuart mentioned, the real customer test they want to put in SLT is sometimes proprietary between their OEM what they use, because these are all now tested as a part of support chips, what OS, what workload we need to run on what area of the blocks within the chip. So I hope we have given some answer to that.
Yeah, it's very helpful. Thank you, Jürgen. And yeah, thank you to all our speakers. I think we'll close here. We do want to close on time. That's one of the things we always do in DV Club, and we want to keep the same discipline in Test Club. Do you want to make me the presenter, please, Disha?
Yes, Mike, I have made the presenter.
Okay, so thank you for participating in Test Club, our first Test Club. I hope you found it useful and certainly a useful time of your hour, an hour well spent. We are quite disciplined on making sure that we stick to time so that you can slot them in between your normal company meetings. Okay, so as I mentioned, the presentations, both the slides as PDF and the recordings, the video recordings will be available afterwards. You just have to go to our TestSolve page. There, you can see the link. You will be emailed the link as well, so you'll be able to get that link via an email that will send you. If you do have any ideas, I mean, this is our first one. We started with SLT. I'm sure there's lots of other topics which you may be interested in, and we'll ask you for some suggestions. This is very much the idea behind Club here is that it's a community-based event, and we really want to understand what it is you want to hear about, and also if you want to give a talk. We'd like to hear from you, from the community who want to give talks as well as us. Okay. So this is built on DV Club, so these may look a little bit different to you, but they may be of interest to your pre-silicon verification guys. But this gives you a flavour of the types of things we do. So on the 5th of September, for example, in DV Club, we're talking about cache coherency verification. And on the 28th of November, we've got talks on the auto-generation of verification infrastructure, VIP if you like, from IP level up to SoC level and pre-silicon verification. And we have an annual conference as well. Well, actually, two now, because the first one was in Reading in June, where we had over 1,200 registrations, and we're now starting our first ever one in Austin, in the US, where you can either be there physically and you can turn up at the Marriott Hotel, or you can log in remotely. So these all have remote login as well, so that you can attend from anywhere in the world. So just finally, thank you to our speakers, Vinod, Jürgen and Stuart, and thank you to our partner Stuart from AEM, and thank you to you for joining the first test club. Hopefully you'll join many more, and we can build this community. Thank you, Disha. Thanks everybody. Thank you.
Thank you. Thank you, everyone.